Hi, this is Ram from Crossmind Studio. Welcome back to another chapter of Geometry Node series, and this is chapter number 6. And as we were discussing math, and in the previous chapter we made this simple animation of the clock running for a minute. So in this chapter we are going to discuss how we can use math to change the shape of a mesh. Usually when we are working without the geometry node, when we are changing a shape of an object, you just simply go to the edit mode and start moving things up and down and try to change the shape of it. Basically there is nothing technical you are doing. You're simply taking decision based on the visual that you have in front. But when you're working with the procedural nodes, often you will be dealing with the math. So let's bring a geometry node network here. What if you wanted to move this thing up? So you would bring a transform node and then go to the Z direction and start changing that value. And what this does is this changes the position, rotation and scale of an object. But if you wanted control on each of these points, maybe move this up and move this down, then instead of transform node, you will have to choose a node which works on each of these points separately. So set position basically works on the points and not the entire object. So now you have a position input, and here, just like before I mentioned, this is a vector input. So we'll have to go to the vector math and plug this here. And as soon as I do that, you'll see everything disappear. That's because the values here are 0, 0, 0. So let me just disconnect it to clarify a few things. Even though we are visually dealing with the meshes normally, but the computer is still working some math in the background. So if I bring a 3D cursor here and try to snap this on this vertex, you'll see the location of this vertex is something like this much meter in the x direction, y direction, and z direction is almost 0. That's because we haven't moved. This is like set to 0. If I move this plane up and snap it now, then you'll have much more higher value in the z direction. Then similarly, quite opposite of that we'll get. So maybe like this is 1, 2, 3, just like how we deal with the graphs. So 1, 2, 3. I'm just giving an example, and this would be -1, -2 position, -3, x, y, and z. So this is x, this is y, and this is z. So even when we are moving things with a simple movement command and all that, so what is happening is the vector of those points is changing. The vector of this point, and this point is changing, and based on those vertices, the render engine and whatever this is creating a face that will render in the software. All right. So quite simple thing. So what if I wanted these points to move upwards? I'll simply have to plug this here, the vector math. So since everything is 0, 0, 0 now, everything I've shrunk down to this singular value, 1, 1, 1. Let's make it. So now it doesn't matter what values we bring in here, you'll see nothing is happening. It's not really changing, bringing our mesh back. That's because the position vector doesn't really know based on what to assign the position of these vertices. So it doesn't matter what values you insert here, nothing is going to happen. So our mesh is gone. So instead of that, what if we bring input and position, plug this one into position, and what this does is, just like how we worked in MantaFlow before when we were dealing with the shading and attributes and all that, if you've seen those tutorials, this basically gives us a network to play around with based on whatever is the current position of the node of the geometry, all that information. That is what we are going to get with this. So no change will happen. The only thing you're going to get is this line within which you can do more math. All right. So before this, you didn't really had any access. You can't really do this, click this, or do anything. But since now you have extracted that information of the position in this connection, you can add more stuff. So now if I go to the vector and do vector math and plug it here, then you can see if I move it 2 in the z direction, so all of these points are moving in the z direction. If I make it x, then I get the x direction, y and y direction. But the thing is, at this moment, all of these points are moving exactly the same in the similar direction. Because of that, everything is still flat as plane. There is no variety in the position of the points that we have. So what if we wanted this to have an organic shape, like maybe mountains or something? Then what we will have to do is we'll have to bring in an input that is organic. So such as using a texture. So right now we have only one texture, but more textures are being added to the geometry nodes. So by the time, if you're watching this tutorial, maybe 2 or 3 months later, you might would have more textures, just like you have more textures in the shader nodes. But this texture, the factor value is, as we mentioned before, is in the gray color. That means this is a float, and this can't really work with a vector precisely. You can see the gray color here, and this is a vector value. First, I would need a converter, combine XYZ, just like the previous chapter, and then plug this one into Z direction. Now, if I make this one a 4D texture and try to change the timing of the texture, you can see all of these 4 points are moving in with the different values. So there is some sort of texture going on, just like the noise texture that we have in the shader nodes. If I bring the spreadsheet, all of these 4 points have different values going on. Now, just to visualize this better, what I'll do is, instead of this geometry, I'll bring a grid from the primitive section and add more vertices here, maybe 50 by 50. And now if I change the value, you can see all of these points are moving based on this texture that we have. Now you can scale it up, scale it down, add more details, add more distortion, and do all sort of things. So just to clarify again, this position input is basically giving us the original position of the points, and on top of that we are working with the vector math. And to have an organic input, we are going to use this texture. But since we can't work with the float and vectors are not really compatible and doesn't really work more accurately, we are going to combine XYZ and work in the Z direction. Alright, so that is all we did. Now let's start adding more details. So on this grid plane, I'll add more subdivisions, vertices X, vertices Y, or maybe let's make it 200. How about some really good looking mountains with super rich details? There you go. Just like how we work with the color ramps in the shader editor, if you would like to tweak these values, work with more extremes, you can do that. You can bring in more contrast with the color nodes or even the RGB curves if you prefer. So you have a beautiful looking landscape, and this is just a start. We will be able to add much more details, like maybe scatter trees on the top of the hills and maybe add water in the lower areas and stuff like that. So we'll talk about that, but let's take one step at a time. Let's get the fundamentals straight first. All right. So this is a simple plane and we are tweaking the geometry in the Z direction. So how about a different kind of geometry where we have, now instead of a flat plane, what if we use a round object? So I just want to clarify one thing, and I'll do the exact same thing, set position, which we already have here, bring a texture, bring one vector math, plug it in here, and then bring a position input of the vertices that we have, plug it here, and vector combine XYZ here, and exact same thing that we did before. Now you might be thinking like this doesn't really look like a displacement, that you might be expecting this to work in all these 3 different directions. For that to work, we'll have to use the same texture in all these 3 different directions and change the math node to multiply. So what add means is wherever this point is, just it's going to add on top of that value, and that will give you this effect which looks like the mesh is shifting its position. But instead of that, what you can do is simply multiply the texture with the original position, and that will give you an effect of displacement. Now you might be thinking, then what is the reason of using this node in this case if we were using the same value in all these 3 XYZ? You're absolutely right, we don't need this node anymore. The whole point of this node was, the combine XYZ node was to have access to 3 different float inputs that are there in the vector. So since we are using the same value, using this to displace all the 3 axes, in this case we can actually get rid of this. Just Control X and this should work exactly same way. All right. So just a Very simple thing. I just wanted to clarify for some reason. And yeah, that's about it. And you have this displacement going on. Now you can do all sort of things, color ramp and clamp things up and down. Maybe make a nice planet, or combine multiple textures. Yeah, all those things you were able to do in the displacement with the shader nodes, you should be able to achieve those results and make a planet out of it. And also, like I said before, the more textures will be coming to this section, and I just can't wait to make those amazing abstracts with the textures. I hope we get to see those textures soon. So just in case if you are having fun with this chapter and you just wanted to make some good render out of this, a few things you can do is, first thing, these vertices in X and Y, so we could increase the segments. So if your computer can afford it, just bump these values up. So just be careful with it, otherwise if your computer is like not, the configuration is really basic, then your Blender might could crash. And then after that, maybe bring RGB curves and start tweaking these values in the geometry node editor. So I like this kind of composition which I have already prepared for it, and I like this one. And now all I need to do is assign some material. So first thing, I'm going to bring material assign just like before in this node network, and choose the material that I have in the scene. So right now it's a flat material. I need to add some texture or something in the environment and the textures. So shader editor we need right now. Let's go to the object. So we have this basic material. If I render this now, and I'm using cycles render, and the background is black, so let's go to the world first and bring a sky texture. I'm going to speed this thing up because this is not really a rendering chapter, but just for those. So in case you're having difficulty, go back to the basics of the Blender. Playlist is the playlist section. All of this was discussed already. So yeah, so just bring a sun, and now that we have some sunlight going on, go back to the object in the shader editor, and maybe we can bring some texture. So noise should be enough. I'll just type it out here. Color in the base color, and even though we have the noise texture, it's quite subtle, so we can bring a converter color ramp so that there's more contrast into this. So yeah, this is fine. And maybe we can increase the details in the texture, distortion, roughness, details and all that. There you go, you have some good looking mountains. Now instead of white color, so maybe green color here, and some darkish sand color here. So here I have some values which I think are working for me, and what we can do is we can bring another copy of this one and put this down in the scale. So yeah, this looks good. Now just bring a camera, start framing things, and maybe you can add a cube for some fog in the scene, like with the volume scatter and all that. And I think this is looking good. And for a 10 minutes or 15 minutes of effort, I think we have something solid going on here to render out maybe some aerial shots for some planet, or I'm just giving you ideas. So have fun with it, and do share your renders with me on Instagram. Tag me with Crossmind. In the next chapter, we are going to create an abstract animation using this kind of math, and also a bit of point scattering on the surface. I mean the point instances, and converting your mesh into points. So a very basic example is going to be a very simple kind of animation, maybe something like a audio visualizer or a plexus animation. So that is what we are going to do in the next chapter. So tune in, and let's talk more and make some more use of these math nodes, and get used to it so that we have our brain running and working and doing its homework for the more exciting stuff. I'll see you guys in the next chapter. Click right here and let's jump to the next video.